Good morning, sir. Myself G. Lavanya from first year Department of Computer Science and Engineering, and today I'm here to give a presentation on Zener Effect. Introduction to the Zener Effect. The Zener Effect is a phenomenon observed in semiconductors and diodes. It occurs when a reverse bias diode allows current to flow after a certain breakdown voltage is reached. The effect is named after Clarence Zener, who predicted in 1934. Here we see the circuit diagram of the Zener effect. Here unregulated voltage connected to the resistance RS and load L and a diode. Zener diode overview. Zener diodes are specially designed to operate using the Zener effect. They are used primarily to regulate voltage in circuits. The breakdown voltage of a Zener diode is a preciously controlled during manufacturing. And mechanism of the Zener effect. The Zener effect involves the creation of electron-hole pairs in a semiconductor material at high reverse voltage. The strong electric field enables these pairs to contribute to current flow. This mechanism is different from avalanche breakdown, which occurs in regular diodes at higher voltages. Here we see the differences between avalanche breakdown and Zener breakdown. In this diagram, we see p-type is connected to negative and positive is connected to n-type. Here we observe large deflection layer, and for electron by hits the atom at a high speed in p-type region, and in n-type, p-type is connected to negative, n-type is connected to positive, and we see the narrow deflection region and strong electric field is twice electron from the ion. Here we see in the Zener breakdown. Zener breakdown voltage. The Zener breakdown voltage is a critical parameter for Zener diodes. It determines the voltage at which the diode can conduct in reverse bias without damage. Selecting the appropriate Zener voltage is essential for effective circuit design. Here we see the graph plot in the diagram, avalanche and Zener breakdown. In forward region and reverse region, this graph is plotted. And forward bias, we see the graphs increases and the Zener breakdown avalanche reverse region. And applications of Zener effect. The Zener effect is widely used in voltage regulation circuits. It can also serve as a reference voltage in precious analog applications. Additionally, Zener diodes are utilized in surge protection circuits. And here we see the Zener effect applications of circuit diagram. Unregulated voltage VL is connected to resistor RS, and resistor RS is connected to diode, and diode and connected to load. This is regulated voltage VL. And characteristics of Zener diodes. Zener diodes exhibit a sharp breakdown characteristic in their IV curve. They maintain a relatively constant output voltage across a specified range of current. This stability makes them ideal for various electronic applications. This is the characteristics of the Zener diodes. Comparison with avalanche breakdown. Unlike the Zener effect, avalanche breakdown occurs at higher voltages and involves different mechanisms. Avalanche breakdown is typically seen in regular diodes rather than Zener diodes. Understanding these differences is essential for selecting the right component of a circuit. Here we see the diagrams of the avalanche breakdown. In this first diagram, we observe heat observed from environment. Electron absorb heat from charge carrier. The kinetic energy of the electron we see in the second diagram. This is reverse biasing. In this diagram, gain kinetic energy and heat absorbed from environment also. This one also. And advantages of Zener diodes. Zener diodes provides excellent voltage regulation capabilities. They are available in a wide range of breakdown voltage for diverse applications. Their robustness makes them suitable for high frequency circuits and environments. And what are the applications of generators? Here we see in the circuit diagram. In this circuit diagram, we see DC supply is connected to the resistors and connected to variables RL. This is the circuit diagram of application of Zener diode. And limitations of Zener diodes. Zener diodes have a maximum power rating that if exceeds can lead to failure. They may exhibit temperature sensitivity, affecting their performance in varying conditions. Careful circuit design is necessary to mitigate these limitations effectively. And here saw the graph plot between this XY axis and the symbol cathode anode or forward current, reverse current, and constant Zener voltage. Zener, in this region, we observe Zener breakdown voltage. And future trends in diodes. Research is ongoing to improve the efficiency and thermal stability of diodes. Advancements in materials science may lead to the development of new types of diodes. Future applications may include integration into more complex semiconductor devices. And this is the topic. Thank you, sir.